Warning, this video is not a walkthrough on your data, conclusion, and explanation of your lab. It is simply a walkthrough and a student aid to help you along with your procedures in case you get lost. So if you experience any trouble such as confusion, human error, missing equipment, nausea, heartburn, indigestion, upset stomach, diarrhea, peptic smell, or even death, please contact your local teacher. For your discretion is advised, batteries not included. Hello and welcome to the Standardizing Acid Base and Titration Curve Lab. The purpose of this video is to help you and your lab group prepare yourselves for these three separate but similar labs. In this video, you will learn to prepare, set up, and analyze data for each lab. You will also learn the certain and simple differences to each lab procedure. It's important to know these differences to prevent confusion. So let's get started. First, you will need all the supplies needed to carry out each of these labs. You'll need 200 ml volumetric flasks, 150 ml beret, along with the beret stand, KHP which is evaporated, 2 Erlenmeyer flasks, a 10 ml graduated cylinder, a balance with a precision of plus or minus 0.01 grams, phenolphthalein, distilled water, a hot plate or an oven to heat the KHP, tongs for the oven, and a pH meter. Creating your solution. To create your acid-base solution, use a scale to weigh the correct amount of acid or base needed to make X molarity solution. Then create your solution by putting the substance into the volumetric flasks, adding the water to the 100 ml mark, then mixing it well. Do this for both solutions. If the substance you chose is agroscopic, such as NaOH, standardize it using KHP. Mass and heat the KHP in an oven first. Put the KHP in the oven in 5-minute intervals and weigh them until the mass stays constant. You will then titrate your KHP with your basic solution. First, rinse your beret with your base and put your already heated KHP in and a few drops of phenolphthalein as your indicator. Place the Erlenmeyer flask under the beret and add a few drops of phenolphthalein and titrate the mixture with NaOH, allowing small amounts of your base to flow into the flask. Be sure to stir the flask after each adding of your base. Record the volume of base it takes to completely turn the solution purple. Then figure out your experimental molarity for your base. This will be your true molarity of your base. Now for the actual titration part. First, make sure all glassware are rinsed off with distilled water. After you dried them, then rinse each glassware respectable to what they will be holding. For example, if a beaker will be holding an acid, rinse it with that acid. Before filling each glassware with their respectable solution, figure out the amount of analyte is most appropriate, say about 10 milliliters, and predict how much of the titrant, based on the molarities of each solution, is needed to fully titrate the analyte. After rinsing it, now put your pH meter in the beaker and titrate your solution. Slowly and carefully titrate your analyte by adding drops of titrant. Record your pH of analyte with reasonable and equal intervals. For example, if you're using 10 milliliters of HCl or NaOH depending on your analyte, record your pH at every 1 milliliter titrant added. Graph your recordings using a titration curve, shown here. When no base has been added, the pH is low, around 1 or 2. Then after some base has been added, the pH will rise a small amount. After a few drops more, the base is added, the pH jumps to around 9 or 10. This is due to the vertical slope near the equivalence point of the titration. After equivalence point, adding more base will only increase the pH slightly, as shown in the titration curve. The pH slowly increases until the equivalence point, where it rises sharply and then levels off again. Congratulations! Now you know exactly how to perform an acid-base titration lab.